Okay, welcome to this third part. Finally, we are checking some code here. And so let's get started. So in order to handle everything, I implemented a really simple matrix class, just handling the stuff I wanted. And as we discussed, we are handling a row buffer, which is nothing more than a list with the element in row major order. Then we just pass in, right, the number of rows and columns our matrix has. And as we said before, we're going to use that in order to easily and correctly access the element in the matrix. So the constructor only does that. It stores those elements and that's the end of it. We don't need to worry about identity function class method. It's just a utility to make function, identity matrix. We don't worry about special method for printing. Extend matrix horizontal is something for make augmented matrices, so concatenating matrix horizontally. That's not something we use. That's the next things I'm working on, the actual Gaussian Jordan elimination, which actually transform not in an upper triangular form, but in an identity matrix. So don't worry about that. We're not going to use that. Here we have a utility method, getRow, and basically extract a row from the matrix and returns it, right? So if you follow my previous video, this kind of offsetting should make perfect sense. We offset by the number of rows, IDX is the row we want to extract, by the width of the matrix, and then we grab the whole row. So basically the offset of the row plus the width of the row, and we extract a list with that. That's the whole thing. And we have a similar method called setRow, which does the same thing. Basically, it loops the columns, right? Then we offset by the correct row offset and the correct column, adding the correct column, and we copy the element. So we just find the right place in the matrix, we loop one by one, and we copy the value. So that's just utility function, nothing to worry about. Alright, easy stuff. So let's actually go into the meat of our Gaussian elimination, right? So you see it's not much, it's like 40 lines of code. Yeah, from line 46 to 90, like 45 lines of code, something like that. So as you would expect, we start by looping the columns, right? Because as we explained it earlier, we start working from this column, that's this column, and basically we want to zero out the element below the diagonal. So we want to zero out this, then the second row we process, we want to zero out this one, right? So that's, we loop the columns. So we have a J element, which is our column index, perfect. Here is the pivoting. So right now, let's not worry about the pivoting, right? Let's just comment that out. So let's start simple. So what we do, we grab the row, which I call the pivot row, but just calling the current row, doesn't matter, right? Or the row we want to subtract. Then what we need to do is to loop all the remaining rows, right? So let's say I'm processing here, so it means in diagonal we are at the element 0, 0, and we want to loop all the rows below this one. So in the case of a 3 by 3, we want to loop index 1 and 2. If you were at column 1 here, we want just to loop index 2, because that's the only one. If you are row 3, we actually stop and we don't do anything. There is nothing below index 3 we want to zero out. And as you can see, we are looping the one below the diagonal, so J plus 1, right? So the first iteration, J is going to be 0, J plus 1 is going to be 1, and we loop for the remaining rows. So next, we're just going to extract the rows. So it makes our life easier. So we have the row we want to subtract, and we have the row we want to subtract from. So current row in the first iteration, basically row 1, and pivot row is row 0. So we're just going to compute the ratio as we explained it. right? So we access the jth element, right? So basically the element in the row corresponding to the column. So it's the column 0, we access the first element. If it's column 1, we access the element 1 and then element 2, right? So if it's second row, we access the second element, and so on. So that's why we use the j component, and we just compute a ratio. In this case, let's go back again here. So let's say this is a 1, 4, 7. We are just going to do 4 divided by 1. 4 divided by 1. That's it. That's our ratio. And then we just have a utility function, subtract rows, right? Because basically now we want to do row 1 minus row 2 times the ratio. And that's exactly the argument we are going to pass. We are going to pass j, which is the source, the row we want to subtract. I is the destination, the row we want to subtract from. We have the ratio, so how much we subtract, the ratio of the first row, the row we subtract, and then the solution vector. Because as I said before, we need to take care, apply the same operation. So if we subtract this, we need to subtract those values as well from the solution vector. And we are going to see that how we do it. It's really easy. So let's go quickly check subtract row. So it's documented, it says everything, you can check the code. Again, here we re-extract the row. I know it's not ideal, that's room for improvement. We already have this row, we can pass this as an argument, but just to keep stuff simpler, what we do, we loop the columns, right? Because we want to subtract this element with this element, this element with this element. So we are going this way, right? So we are looping the columns. And what we do is that the current element is going to be equal the current element itself minus the source row element. So we're accessing the ith element of the source row, we scale that by the ratio and we subtract it and we sum in place, right? Here, if you like it better, we can just do minus equal, right? I didn't do it just because showing explicitly, right, will make life easier, I've thought. And that's it, right? So we subtracted the row, right? Hold on a second. I forgot to say, here we also apply the same operation, right, to the solution vector, which is exactly the same formula, right? The current index, so destination index, minus the source index times the ratio. Same exact thing. But when this code is execute for each columns, so it will execute for all 3 columns, processing the the rows below the diagonal, right? What we're going to end up in this case is 1, 2, 3, 0, 5, 6, 0, 0. So that should be 6, 7, 8, 9. So that's the kind of metric we're going to have at the end. So we zero it out. That's the first goal. Next video we're going to talk about back substitution. It probably is going to be a theoretical video first, so to explain it better, and then we see the actual code. Or maybe if it's not too long, we can do in a single video. Alright? I hope it's clear. As I said, it's really hard to explain these kind of things, at least for me. I don't know if for everyone. So any advice, any feedback will be really appreciated, and I hope it was useful to someone. Alright? See you in the next video, guys.